Hey everyone, welcome to the first episode of our Midnight Developer Workshop series. Today we're going to spend an hour with Midnight Wallet CLI. This is a command line wallet that lets you do everything from managing wallets to transferring tokens to spinning up a local Midnight network, all from your terminal. By the end of this session, you will have a running local network, a couple of wallets, and you will have sent your first tokens transfer. So let's jump in. Before we touch the CLI, let's make sure we are all on the same page about what Midnight actually is. Midnight is a privacy-focused blockchain that uses zero-knowledge proof. And the key idea here, the thing that makes it different, is that it has two types of states. You've got the public chain data, which everyone can see, and then you've got encrypted private data that only the parties involved can access. So you get the transparency of a public blockchain where you need it and the real privacy where you need it. For tokens, there are two you need to know about. Night is a value token. That's what you hold and transfer. And then there's Dust, which is used to pay transaction fees. We will talk more about Dust later because it has some interesting behavior. Midnight is built by IOG, the same team behind Cardano, and it's officially a Cardano partnerchain. That means native interoperability with Cardano, and Cardano stake pools operators actually serve as block producers of Midnight. Now, here's an interesting technical details. The node itself is built using the Polkadot SDK, also known as Substrate. So you've got Cardano ecosystem and community with Polkadot's proven node framework under the hood. Best of both worlds. But for today, all of that is background. We are going to focus on the tools. So you might be wondering, why a CLI wallet? If you have used Midnight before, you probably use Lace, the browser extension wallet. Lace is great for end users, but when you are building things, you want something you can script. And that's exactly what this tool gives you. First, no browser needed. Everything runs in your terminal. Second, it's scriptable. Every command can output JSON. You can pipe it to JQ, use it in shell scripts, hook it into CI/CD pipelines. And here's the part that gets me excited. It comes with an MCP server. That means AI agents like Claude can directly interact with my Midnight network through this tool. 24 tools exposed over MCP. We will get into that later. If you have used Lace before, a lot of these will feel familiar. Same concepts, just a different interface. Let me give you the quick rundown of what this tool can do. 6 main things. 1. Multi-wallet management. You can create as many wallets as you need, give them names, switch between them. 2. Token transfers. Send nights between addresses, check balances, request airdrops on test networks. 3. Local network. One command spin ups a full Midnight network on your machine using Docker. No cloud, no testnet, just your laptop. 4. DApp connector. It runs a WebSocket server that speaks the same protocol as the Lace wallet, so your DApp can talk to it without any code changes. 5. MCP server for AI agents. We mentioned this already. And 6. JSON output. Every single command supports a JSON flag, so you always get machine-readable output. Let's look at what's actually running under the hood. When you start a local network, 3 Docker containers come up. First, the node itself. That's on port 9944. This is the actual blockchain node. Then the indexer on port 8088. This watches the chain and makes it easy to query balances, transactions history, that kind of thing. And finally, the proof server on port 6300. This is the one that generates your zero-knowledge proof when you make transactions. The CLI talks to all 3 of these. And the nice thing is you don't have to manage any of these manually. The command Midnight LocalNet app handles everything. There are three networks you can connect to. First is undeployed. That's your local network, the one Docker runs on your machine. Then there's pre-prod and preview, which are both public testnets. Here's something neat about the wallet design. Wallets are network agnostic. You generate one wallet with a mnemonic seed phrase, and that same seed derives different addresses for each network. So you will see addresses that starts with address undeployed, or address preprod, or also address preview, depending on which network you are pointing at. Same wallet, different addresses. The commands are organized into a few groups. You've got your wallet commands, for example, generate, list, use, info, remove. You also have network commands for the local setup, for example, local net up, down, status. You have transaction commands, for example, balance, transfer, airdrop, and then also the server commands, serve for the DApp connector and the MCP binary. Everything is accessible right from your terminal. And there's a short alias too. Instead of typing midnight, you can just type MN, same thing. So who should actually care about this tool? Three main groups. If you're a DApp developer, this is your local development environment. Spin up a network, deploy contracts, test transactions, all without leaving your editor. If you are a DevOps engineer, the JSON output and scriptability means you can automate wallet operations, build deployments pipelines, run health checks. And if you're building AI agents, this is probably the easiest way to give an AI access to a blockchain. Set up the MCP server, point your agent at it, and it can manage wallets and send transactions on its own. One more thing before we go deeper. This is a community tool. It's listed in the Midnight Awesome DApp collection. It's open source and you install it from npm. Just run the command npm install midnight-wallet-cli and you are good to go. It installs two binaries, midnight or MN for short, and midnight wallet MCP for the AI agent integration. All right, that's the overview. Now let's get into the details. Okay, let's go deeper. Let's start with the wallet management because you are going to use this constantly. The workflow is simple. You generate a wallet, give it a name, and then you switch between wallets with the command use. You might say midnight wallet generate Alice, midnight wallet generate Bob, and then midnight wallet use Alice to make Alice the active wallet. When you run wallet list, you see all your wallets with a little arrow pointing at whichever one is active. And wallet info gives you the details, the address for whatever network you are on, the mnemonic phrase, the derivation path. All of these get stored in the Midnight directory on your machine. So your wallets persist between sessions. If you need to clean one up, wallet remove handles that. Let's talk about how the key derivation works, because this is a smart design choice. The wallet uses BIP39 mnemonics, that's the standard 24-word seed phrase, and BIP44 derivation path. What this means in practice is that one seed phrase gives you a unique address on every network. The derivation path includes the network, so undeploy, preprod, and preview all get different addresses from the same mnemonic. And here's something important if you're already using Lace. Since version 0.2.5, the CLI wallet is compatible with Lace. Same mnemonic, same derivation, same addresses. So you can import your Lace wallet into the CLI and vice versa. If you're upgrading from an older version, the tool automatically migrates your wallet files to the new format. You don't have to do anything. The local network is one of the killer features of this tool. One command, midnight local net app, and you have got a full midnight blockchain running on your machine. It starts three containers: the node on port 9944, the indexer on 8088, and the proof server on 6300. These take a minute or two to come up and sync with each other. You will see the CLI waiting for everything to be ready. Once it's running, you can check Midnight LocalNet status to see the health of each service. When you're done, Midnight LocalNet stop passes the containers, and Midnight LocalNet down remove them entirely. Stop is nice because it preserves state. You can start again later and pick up where you left off. There's also Genesis Wallet built into every local network. It's generated from the seed01. This wallet starts with tokens, so it's useful for initial funding. But for our demos, we will use the airdrop command instead, which is simpler. When you send a transaction on Midnight, there are 5 steps happening behind the scenes. Let me walk through them so you understand what the CLI is doing when you hit enter on a transfer. Step 1, check the balance. Make sure you actually have enough night to send. Step 2, build the transaction. This creates the raw transaction data with all the right parameters. Step 3, generate the zero-knowledge proof. This is the privacy part. The proof server creates the zero-knowledge proof that validates the transaction without revealing private data. This step can take a few seconds. Step 4, submit. The signed, proven transaction gets sent into the node. Step 5, confirmation. The CLI waits for the transaction to be included in a block and confirms it went through. You don't have to manage any of these steps yourself. Midnight Transfer handles all of it, but it's good to understand what's happening, especially when we talk about why some transaction takes a moment. Okay, let's talk about Dust, because this trips people up the first time. Dust is the fee token on Midnight. You need to pay it for transaction. But here's the thing. You cannot just buy Dust or transfer it directly. Instead, when you hold Night tokens, your account generates Dust over time. Think of it like staking rewards, but for fee credits. Before your account can start generating Dust, you need to register for it. The CLI handles this automatically when you do an airdrop, but it takes about 5 minutes on a fresh local network for the Dust to actually start appearing. So here's the scenario you will hit. Your airdrop have some nights. You try to send a transfer right away, and you get an error, especially error 138. That's balance check over spend. This is a fancy way of saying you don't have enough Dust yet. The CLI has a built-in retry mechanism for this. When you do a transfer, it will wait and retry if Dust is not ready. But just know that on a fresh network, there is a short warm-up period. We will see this in a demo. The DApp connector is really useful if you are building application on Midnight. When you run Midnight Serve, it starts a WebSocket server on port 9932 that speaks the same JSON-RPC protocol as the Lace browser wallet. Why does this matter? Because your DApp code doesn't care whether it's talking to Lace in a browser or to the CLI on a server. Same API, same codes. So you can develop and test your DApp entirely from the command line, and it will work with the Lace in production without changes. There are a couple of flags worth knowing. Approve all, automatically approve every transaction request. Great for testing, obviously not for production. And no auto-approve reads. Make it so even the read operation need approval, which is useful if you want to see every interaction. On the client side, there's an NPM package called Midnight Wallet Connector that gives you a clean API for connecting to this server from your DApp code. Let me show you how the pieces fit together. Your DApp connects to the Midnight Serve process over WebSocket. That process then talks to the node, the indexer, and the proof server, the same 3 services we discussed earlier. So the DApp connector is really a bridge. It translates wallet operation from your DApp into the right codes to the Midnight infrastructure. And because it's running as a process on your machine, it can hold your keys and sign transactions without exposing them to the DApp. Every command in the CLI supports a JSON flag. When you use it, two things happen. First, all the human readable output goes away. std error gets suppressed. Second, std out gives you exactly one line of JSON. For a successful command, you get an object with OK true and a data field with whatever the result is. For errors, you get OK false, an error code and a message. This is huge for automation. You can write a shell script that checks a balance, parses the JSON with JQ, and makes a decision based on the result. No scraping terminal output, no rejects, just clean structured data. The error codes are consistent too. For example, 138 is always balance, check overspend. 404 is wallet not found, and so on. You can build reliable error handling around this. Now, let's talk about the MCP server, because this is where things get really interesting. MCP stands for Model Context Protocol. It's an open standard for giving AI models access to tools. And Midnight Wallet CLI ships with a built-in MCP server. Is the secondary binary that gets installed, called Midnight Wallet MCP. This server exposes 24 tools over JSON-RPC using STDIO. So when you connect an AI agent like Claude to this MCP server, the agent can do everything the CLI can do. Generate wallets, check balances, check transfers, start the local network, all of it. The protocol is simple. The AI sends a JSON request describing which tool to call and what parameters to use, and the MCP server executes it and sends back the results. It's like giving an AI its own terminal, but specifically for midnight operations. Setting up the MCP server is the same basic idea regardless of which tool you're using. You create a configuration file that tells your AI client where to find the MCP binary. For Cloud Code, you add it to MCP JSON file. For Cloud Desktop, it goes in the app settings. Cursor, VS Code with Copilot, Windsurf, they all have their own config locations, but the JSON structure is basically identical. You just point to the Midnight Wallet MCP binary and you are done. We will look at the actual config file in the hands-on section. The 24 MCP tools are organized in the same categories as the CLI commands. You've got wallet tools, for example, generate, list, use, info, remove. You also have network tools, local net app, down, status. You have transaction tools, balance, transfer, airdrops, and also you have configuration tools. Each tool has a clear name and description, so the AI agent knows what it does and when to use it. You don't have to teach the agent about Midnight. It can read the tool description and figure out the right workflow. Let me paint a picture of what an AI agent workflow looks like. You tell Claude, set up a local Midnight network, create two wallets, fund one, and transfer 109 to the other. The agent thinks about it and starts calling tools. First, local net app to start the network. Then, wallet generate twice, once for Alice, once for Bob. Then, airdrop to fund Alice's wallet. It waits for dust to be ready, checks the balance, and then calls transfer to send 109 from Alice to Bob. Finally, it checks both balances to confirm everything worked. All of that happens without you typing a single command. The agent figures out the sequence, handles the waiting, deals with errors. Pretty cool, right? Quick bit of history. The tool started at version 0.1.5 as a basic CLI wallet. Over time, it picked up the DApp connector, JSON outputs, MCP supports, multi-wallet management. Version 0.2.5, the current release, is the one that brought lace compatibility with the BIP39 mnemonics and BIP44 derivations. That's the mainnet ready version. So this is not just a toy project. It's been through several iterations and it's designed for real use. All right, enough slides. Let's actually use this thing. All right, hands-on time. Go ahead and open your terminal if you're following along. Before we start, make sure you have three things. Node.js version 20 or higher. You can check with Node version. Docker running on your machine. Docker version to verify. And a terminal you are comfortable in. That's it. If you've got those, you're good. Okay, let's start with the section Install and Setup. Here you can see a brief summary of what we are going to do. Okay, let's switch to the terminal. Okay, let's continue with the section Start Local Network. You can also see in this slide a brief summary of what we are going to do. Okay, let's switch to the terminal. Okay, let's continue with the section Wallet Operation. In this slide, you can see a brief summary of what we're going to do. Okay, let's switch to the terminal. Okay, let's continue with the section Fund and Transfer. In this slide, you can see a brief summary of what we're going to do. Okay, let's switch to the terminal. Okay, let's continue with the section JSON output. In this slide, you can see a brief summary of what we're going to do. Okay, let's switch to the terminal. Okay, let's continue with the section DApp connector. In this slide, you can visualize a brief summary of what we are going to do. Okay, let's switch to the terminal. Okay, let's continue with the section MCP server. In this slide, you can see a brief summary of what we're going to do. Okay, let's switch to the terminal. Okay, let's continue with the section cleanup. In this slide, you can see a brief summary of what we're going to do. Okay, let's switch to the terminal. Alright, let's recap what we covered today. We installed Midnight Wallet CLI from npm. We spun up a full local Midnight network with one command. We created wallets, funded them, and sent a token transfer. We looked at JSON output for automation. We started a DApp connector server, and we saw how the NTP server works for AI agents. The key takeaway is that this one tool gives you everything you need for Midnight development from the command line. No browser extension, no GUI, just your terminal. Here are some links to keep handy. The npm package is Midnight Wallet CLI. The testnets have web faucets, a faucet preprod Midnight network, and faucet preview Midnight network. And the tool is listed in the Midnight Awesome DApps collection if you want to find any other community tools. Thanks for watching. Drop any questions in the comments. I will do my best to answer them. And if you're following along, go build something. Now you got the tools. See you in the next one.